All right, so here we go, continuing to solve equations. We already solved a couple of exponents. Now it's time for the logs. So there's two types of log equations. There's an equation, the type where you have logs on both sides, like 4, and there's the type that you have just logs on one side. So they're solved pretty similarly. You'll see the difference. So the first thing you need to do when solving a log equation is make sure you condense the logs. So number 4, you can see it's a log base 4 minus a log base 4. So to condense these, you'd make it log base 4 of x plus 1 divided by 3. And this equals log base 4 of 5. So now when you have a log equaling a log, a single log after condensing it equals a single log, you can just set whatever you're taking the log of equal to whatever you're taking the log of over here. So a lot of people think I'm just going to cancel out those logs. That's not what you're doing, but as long as you have a log on both sides and they're the same base, you can think of it that way. Now we have this algebra equation. So we have to get rid of the 3. You multiply by 3. And then finally subtract 1. Now, log equations, you can get extraneous solutions, mostly because you can't take log of a negative number. So sometimes that will happen the same way it happens when you do square root equations. So you want to plug that in. Just make sure it's not making you take log of a negative number. So if I plug 14 into this, I'll get log base 4 of 15. That's fine. And since there's no more x's, then this is perfectly fine. So this is not an extraneous solution. Log base 4 of 15 minus log base 4 of 3 is log base 4 of 15 divided by 3, which equals log base 4 of 5. It checks. I'll show you how to check on the calculator in the next video, or remind you at least. Number 5 is slightly different. It's a log equation. They're both base 2, but there's only a log on one side. So you do the same thing. You always condense. So log base 2 of x plus log base 2 of x minus 7 will give you log base 2 of x times x minus 7. Now this equals 3. So once we have it condensed to a single log, we want to change it to an exponent. So we use that little triangle rule. 2 to the 3 third equals x minus 7, or x times x minus 7. So that base to this exponent of 3 equals x times x minus 7. So now you just solve this equation. Now notice it's a quadratic because 2 cubed is 8, but you have to multiply this x out, x squared minus 7x. So to solve a quadratic equation, you're going to use any method that you know of. I'd use factoring if possible because it's easy. So let's see if it factors. Subtract 8. Look for factors of negative 8 that add up to 7. There are a couple. It's negative 8 and positive 1. So your two solutions are x equals 8 and x equals negative 1. Now, don't stop there because this is a logarithm equation. You could get extraneous solutions. So assuming we did everything right, an extraneous solution would be one that just makes the log equal 0. Or not log equals 0, I'm sorry. That would make you take the log of a negative number, which you can't do. So let's look at the 8. If you plug 8 back into all these x's, you'll have log base 8 plus log base 2 of 8 plus log base 2 of 1. That's okay. 8 is good. Assuming we did the math right, 8 is a solution. Now x equals negative 1. If you try to plug that into the x's right here, it would make you take the log base 2 of -1. You can't do that. You can't take log of a negative number. That means -1 is extraneous. It only has to happen once, but it would also make this negative. So since when we plugged in -1 for x, we're taking log of a negative, that means x equals -1 is extraneous, which means it's not a solution. It's just a solution that comes up even when you do everything right, but after check, you'll find out it's not a solution. So I hope that made sense. The next video we'll do question number 6, and I'll show you some checking on the calculator.